YouTube.
She's using the execution, not the right one. Because on the right edition is 3.11.
So we have this is the mixing technique. We have the tensile strength, and the question says that test the hypothesis that mixing techniques affect the strength of the cement as your alpha is 0.05. So that means you are using the same CRD. Then she used the formula yesterday, although I didn't use it. I've done this thing, and I think her formula makes sense, which is faster. You know, the initial formula she gave to us is for our SS treatment. We are going to use double summation y high dot minus y bar dot square. This, for the first question, is going to take a very long time to do. No, not for the first question. For some of the questions we've done. But then she says you can use 1 over b summation y high dot square minus y bar dot over n. You see, this thing is called the square. This is called the correction factor. They use this to correct the value. We use correction factor a lot in statistics, even especially when you're writing research articles.
This problem is not block.
I know it's not block, but if you use this formula, you can use overhead. If you use this formula, you are going to get the same answer.
But this is the normal randomized design, right?
I know. If you use the same formula, you will get the same answer. But don't worry, don't let us use it for now. Let's go back to what you've been doing.
I don't even know the one we are referring to. But it's the same thing.
She gave us the second one yesterday when we were working. So now, so we have this, and the first thing we have to do is to get our yi dots. I think we have calculator here.
Yeah.
So our yi dot is going to be the sum of it. y2 dot, y3 dot, y4 dots. This for the total. And for the average.
So the sum of the first one?
Yeah.
11,884.
884. What about
Okay. And then what?
just find the average.
Divided by 4?
Divide by 4, yeah.
2971.
2971.
What you got?
Okay. What about y2 dot?
Sum of the second one?
Yeah.
9655.
I don't think my phone is doing well. Okay, 9655.
55. Average 2413.
2413.
Divide point
Point
75.
75. What about y3 dots?
2800 plus 2900 plus 2985.
29.
Wait, hold on. I'm just adding.
That's the average, right?
Okay, you ready? 11,735.
11735.
Average is 2933.
2933.
0.75.
0.75.
266.
Alex, are you confirming those values?
My calculator is just, I don't know.
Is that out of control?
The calculator is just,
Alright, I got 10,
66.5.
66.5.
On average?
266.6.
266.25.
25. Okay, let me confirm the second one because it seems off.
Okay.
32. 1, 2, plus 32. Okay, so the second one's wrong.
This the total?
The y2.
Well, okay.
Yeah, so it should be 12,625.
12,625.
And then the average will be 3156.
3156. Any decimal point?
0.25.
0.25. So now, for you to get your y bar dot, you can add this together, divided by your capital N, which is what? 4 by 4, which is 16. You understand? Or you can sum this together and divide by 4.
Yeah.
Still going to be the same. So let's do this. I think this will be faster.
2971 plus 3156 plus 2.7. I think it's supposed to be 75 here.
Yeah?
Yeah, 0.75.
It's almost insignificant.
Plus the last one. 2. Okay, so divided by 4. Alright, so y dot bar is 2931.9375. So you could just do 94.
Yeah. So now, Alex, for this SS treatment, you can have this as summation n summation n, where we have from I equals 1 to what? A, and J from 1 to what?
B. Wait, no.
N.
Yeah.
So here you can see have your I 1 to 4. So here we have our yi dot bar minus y dot bar all squared. So which is the same thing as 4 into brackets yi dot, that means this 2971 minus 2931.94 squared plus 3156.25 minus 2931.94 squared plus 2933.75 minus 2931.94 squared plus 2666.25 minus 2931.94. I think there's something that she gave to us. There's a question she asked us to practice, and I was sweating because it's not 16. Okay, I think it was this at the initial stage. And known to me that I made a mistake at this second point, and I finished solving. So when I went back to check, and I saw that there's a mistake here, so I have to do everything again. So that's one problem with statistics.
Alright, so the first little thing,
Yeah.
first is 1525.88.
Do you multiply with 4 by 4?
Yeah, just write it down. Just the first parentheses.
Okay.
Yeah, first is,
15 point, or what is it?
let's see, 15.25. Oh, I'm sorry, 1525.
1525.88.
0.88. Okay, and then plus the second one. Yeah.
Why don't you just put everything in?
Because it's too much to calculate.
No, it's not too much for the calculator. That's why it's a calculator.
53.16.
Is it addition of everything? Or
No,
just
that, the next one. So plus 53.16.
53?
50. 50. 316.
316 point.
Oh.
So basically, what we are testing here is that
Oh, yeah,
mu1 is not equal to mu2 is not equal to.
Even I'm supposed to write the hypothesis.
Yeah.
Yeah. That's the first thing I'm supposed to do. Your system is adjusting.
But we are testing h0 is.
Alright, let me just write the hypothesis on.
mu1 equals to, if we are using the,
What are we comparing?
we are testing mixing techniques
Okay.
affect the strength of the cement. That means we want to check at least one of them.
Okay, the treatment. That means for one. This is what I mean, these hypotheses.
So we are using the effect model.
Yeah.
Okay.
So versus the alternate hypothesis, which is at least 1 is not equals to 0. So do you multiply with 4?
Yeah.
So you have what? 4, 8, 9, 7, 14.452. Yeah. I think I got the same. So these are the statements. So secondly, we are going to look
So
for.
I want to ask a question. How do you know the one that is treatment and refutation?
You see, she structured this question in the sense that, okay, she always assumed the row wise, but no, not the row wise. The treatment is, take for instance, you have a plot of land, like the example I gave to you yesterday, okay? And you want to plant maize, don't let me say maize corn, so that we know the banana. We have maize, we have okra. You know okra, Justin?
Okra?
Yeah.
Yeah.
So you want to plant tomato. So these are the what? The treatments. Okay? What you want to plant. So even at times can be the application of fertilizers to something that have already been planted. Understand?
Yeah, so here the mixing strength, the mixing technique is the treatment. Right?
The strength itself.
Or
No.
the mixing technique.
I think these are the missing. We have technique 1.
Yeah.
Yeah. This is going to be it.
The treatment.
This is the treatment. This is the technique 1. So we have different replicates. You understand? So this can be okay. The first tensile strength, different tensile strength. It will be like the first replicate.
So
we have the 4 treatments here.
A is for the here now. A is 4, N is 4. So
Yeah, of course. So these are the first assumptions I need to have written. Here my A is 4, my what? My N is 4. So my capital N, which is AN, is going to be what? 16. So, secondly, we calculate our SS total.
The question is to solve the logarithm.
Yeah, you want to test hypothesis.
You have to do the ANOVA table.
Because you want to test the hypothesis that it affects the strength of the
because you are
sequence.
using F.
Yeah.
You can go ahead and use the F test. Or you.
But you can't get your F test without getting your MS treatment and your MSL.
Yeah.
So we do that the things.
So what is this formula?
So we have Yij minus Y bar. So that is each of the observation. We are going to press everything at the stretch. So here you just have your 3129 minus. You know, I wonder why we still need to go back to this. Because now we use computer for virtual everything. But you know, if you don't understand the background, you won't understand how the computer works too. You rely on the computer. So if there's an error with the computer, you won't be able to detect that. So, can you son? Just, you know, if you are using Casio 991 in Nigeria, we use Casio 991. You can just program this. We just say this minus X.
Yeah,
So you just be pressing solve.
Which one do you want us to solve?
Do you know how to use it with that? You know how to use that Casio 991 to program values like this. You just press a value minus x. So you just be pressing solve, you just be inputting this. So at the end of the day, your x, you just insert the value for the x. These are the shortcuts we use there.
What do you want?
Cashew 9 was so powerful.
Exam, I think exam matter from statistics.
Cashew 9 that calculator. So
What do you want me to calculate?
this minus this plus this minus this, and don't forget to be squaring it. So each of the observation minus the mean. Exam will be faster. Yeah. So let me know.
Minus the grand mean.
Yeah, this is the grand mean. So this is the grand mean. So you just take each of the observations, remove it from the grand mean. Yeah, you know, did she mention grand mean? That means you've done your findings. That is. Welcome to statistical family. We can hijack you for mathematics. Just introduce your do the analysis and we are going to make it look real for you. We make the analysis look real.
I mean, what we did in the one I could understand is the central limit theorem that is stated.
And that central limit theorem, the major summary of the central limit theorem is that, in statistics, we believe the general assumption is that every data set or every observation you have, whereby the distribution is not being stated, we assume that it follows a normal distribution. So that's just the foundation of the central limit theorem.
That means that the averages of the data set follows normal.
Mm-hmm.
Yeah, even if the distribution itself doesn't follow normal.
What's the cost control?
I don't even know the star. I know it's design of experiment. Have you gotten the value?
This is 522.
The SS total?
Is it 5 to 1?
I thought you said the value for the S total is 522.
It's going to take a while.
It's going to take a while.
So what do you want us to compute? The first three, right?
No. I'm
All of
computing
them.
everything. All of them. So when I was doing this, I made a mistake initially. I thought I've gotten my F and I was so relaxed. I was getting 0 point something. Then I realized I made a mistake from the beginning. So I have to start again.
Okay.
But I think what you can just do in Excel, you can name a column with this and just impute all this and you drag. Name a column with this all true. Name another column with each of these observations and perform your basic operation and you drag them. And you find the sum. If your calculator is not good, I think this is another calculator.
No, my own is working now.
Okay, let me try. The grand is 2931.94 squared. At least I want us to have more than one answer just for us to be sure of what we've done. If it is perfect. Are you on the third row? Justin, how far?
I'm coding in the computer, so.
Oh, I couldn't. Unless it's supposed to be true, because I'm almost done. The second.
I'm not efficient with calculator.
Hope I don't make mistakes.
Before today, the last time I used calculator was on the exam day. I'm very rusty.
Three, 2931 and 94. You know, in Nigeria, if you are writing the West African Examination Council and you made a mistake from the beginning like that, maybe due to computation error, and all your other calculation is perfect, you are going to be given your mark for the steps.
That's standard mathematical.
This is not easy. It's only almost 10 minutes now. I'm here. Come on. I don't really make mistakes here. It will be painful before the end of the day. Still on it? I think this calculator is not working.
I got my answer.
You got your answer? So what do you get?
6, 4.
I think it should be right. 6, 4,
3648.
3648.69. Please, let's see other answers too, to be sure. Justin, are you still on it?
So the big part. So if you complete this thing, you do the ANOVA, right? You plug the ANOVA.
Yeah.
Do you need to plug, or you just have to complete the F?
There's no need for it. Since you did not ask us to draw the ANOVA table, she only asked us to get the. And if you don't get this, you can't get the ANOVA table. So it shows you know what you are doing. Oh, And this is the last one. 2931.94. Hope there's no mistake. 64. Perfect. We got the same thing.
Yeah.
Justin, you can drop your computer. Your computer has failed you.
I started over, so I'm just double checking everything.
0.7. Yeah, let's just approximate this. So our SS error is going to be the SS total minus the what? SS treatment.
Yeah.
And that's going to be 643,648.7 minus our SS treatment 489,740.452. That's going to be a partial if I should approximate. But let me make this 0.5. So what do we have?
Yeah.
So we have 489,740.5. 153,908.2 or 19760 down. So
You got the answer already.
yeah. Now that's the SSC.
Your SSC is 1.
So let's compute our MSC here. Our MSC.
What's the degree of freedom for SSC? The degree of freedom is 1 or 2.
Hmm?
Is it 1? A minus 1, which is 2 in this case.
Yeah. For the SS treatment, so we're going to have, the MS treatment is going to be the SS treatment over what? A minus 1, right? And our SS treatment is 489,740.452.
Is it the one that's A minus 1?
Yeah, it's A minus 1.
I thought it's the other one that's A minus 1.
Yeah, it's A minus 1. Treatment total is AN minus 1.
Mm-hmm.
And this one is N minus A. That is an error. So don't mix RCBD with CRD. So your A minus 1 is going to be 3. So 489,740. So this is going to give us what? $489,740.452 over 3. 489,740.452 divided by 3 is going to be 163,246.82. So this is the MS treatment. And my MS error is going to be what? SS error over what? N minus A. Okay? Will you use this? So my SSE is 153,908.2 over N minus A. Our N is 16 minus 4, which is going to be 12. This is like saying 16 minus 4. So we have 153,908.2 divided by 12.
Yeah.
12825.68. So my F, which is going to be the what? The MS treatment over the MS error. MS treatment over MS error, which is 163,246.82 over 12825.68. So 163,246.82 divided by 12.78. I think this is perfect. The answer is right.
I want to make the decision.
The way I'm looking at this, we are going to reject the null hypothesis with the way I'm saying this. Because your f is large.
So we have to compute our f.
Yeah. So now for your the critical point now
will be
is going to be 0.95.
Is it alpha or 1 minus?
1 minus alpha. It's just like it is f1 minus alpha over what? N minus a.
A minus 1, n minus
A minus
1, n minus a.
So it's going to be 4,12.
3,12.
What is happening? 3. Sorry. So that's going to be what? Help us check.
What is it?
The f 0.953,12.
I got the same values you guys got too.
So you got the same value? So what's going to be this? Our f. Let me clean. Can I clean this? Or you are still writing?
No.
Justin, should I do this?
Let me stop.
Don't worry, we're almost. Okay, because of the conclusion, you can take a picture of it. Okay.
Yeah. Good.
I'm good. So let me clean this. So don't forget that our f star, that is our f calculated, I used to call it f calculated, is 12.728. So it's 12.728. When my f tabulated, that means the table value. What is our f table value? What do you get?
Still looking.
So just check row wisely and column wisely with 0.95. Since our experiment is based on alpha is 0.5.
3 and 12.
Yeah, 3 and 12. 0.5.
3.49.
3.49. So now with this, we can see that our f calculated is greater than our f what? The table value. So what do we do?
So 3 point. Wait.
So what's the conclusion? Okay. Okay.
Yeah.
You
So
see,
is it the
to me,
rejection
to me, I don't even make use of the table again.
Yeah, is it the
The
rejection
easy part of it is that when you are comparing with p-value, this is the shortcut. When you compare with p-value, once your p is less than 0.8, less than alpha, you reject. But if it is f, it will be other way around.
Yeah.
If it is greater, you reject.
But this one we have to reject.
So here, since this is greater than this, so we reject what? We reject the null hypothesis. And conclude that what?
Yes. Significant evidence that there is an effect. The treatment has an effect.
So we conclude that there is. You mean there?
Yeah.
Maths?
Yeah.
Can meet our professor? Okay.
I have 10 minutes.
Okay.
We're almost done, then you get
What's the conclusion? So what's the question? We want to conclude that what there's significant difference in the mixture of the cement, right?
Yeah.
So
There is
the mixing technique.
not significant difference, like the treatment has an effect. Different treatment effect.
And there's significant effects in the cement mixture. So we have significant effect in the mixture, in the cement mixture. So that's that. Any other question? Do you have some other sub questions? Huh? That's all.
But the question says test the hypothesis that mixing techniques affect the strength of cement.
That's the hypothesis that what?
Yeah.
Tensile strength being four different mixes can be completely demonstrated. Test the hypothesis that mixing techniques affect the strength of concrete.